We have a question here where we get the position of a drone, x, and that is equal to 2t squared minus by 10t. Okay, and the question is asking at what position does the value of x, what position is that value of x when it changes direction? Okay, so there's two ways to do this because this is a calculator assumed question. So let's dive into the calculator and use the graph setting to find it. And then I'll show you how to do it with calculus. But in this one, we can say graph with calc, and we can draw it. And then we can say, therefore, x is equal to, and let's get straight to it. So go into graph and table, write out our function. Now I'm going to use x here because it's always in terms of x. By default, it's just a lot easier to, in your head, convert it. So I'll click to highlight that, and I'll click this button to plot it. Now it's a little bit off. I can just scroll down here and go there, and I can see that's where it's going to turn. So then when I've clicked on here, if I'm back in this screen, I get the analysis. So I click in here and go analysis, G-solve, and let's find the minimum value. Okay, and we get two values, xc 2.5 and yc equals negative 2.5. So the y value, all right, we can say that the value of which it turns is at t, right? T would be equal to 2.5. But y would be, aka x, would be equal to negative 12.5. Okay, so now we can just graph it really quickly over here. And there we can go. So that's 2 marks. There is another way to do this, all right, and that is to go to the main function, and we can differentiate this, all right, and find when it's equal to 0, because our gradient, right, gradient is equal to the rise over the run. So you can imagine if we can have a positive gradient, the ball wants to roll backwards, and have a gradient that's 0, or we can have a negative gradient where the ball wants to roll to the right. So this is the one that we're interested in, is when it's equal to 0. So let's write in our same equation, and this time we can even use t if you want to, but it's probably just easier to use x because it's just over here on these buttons, so it's a lot easier to use. So x, and then we just highlight this thing and go interactive, transformation, calculation, advanced, we'll get there, and if. I'm going to differentiate it. And so we get, this is our value here. That is equal to this value differentiated. So we can say for our second method of doing this, we can say change in direction. So change in direction. Okay, and we can say, just give it a little tick, right? And we can say when that is equal to 0. And that is equal to, we can differentiate it to say 4t minus x. All right, and then we can solve for t, and t is equal to, don't worry about doing it in your head, just grab it here, say that's equal to this one, it's equal to 0, go interactive, advanced, solve, and solve it. It's equal to 2.5. Remember, I've changed that value to x confusingly enough, but and that's equal to 2.5 there, and so we substitute it back into the original equation. All right, and that will give us that 2.5 squared, and then minus by this. And we can just use our calculator again. And easily enough, you can highlight it down here and say keyboard if you want to get real fancy here. You can get this symbol and say x is equal to 2.5. All right. Or you can individually write it in. So this is the given that symbol. So it just says given that x is equal to 2.5. It's a little hack, but otherwise you can just write it, put it down here, click on each one and say 2.5, and then use your keys to go across. And again, 2.5. And that'll give you that negative 12.5. And the units here is always in kilometers from the question, but I didn't give that to you beforehand. So now it's time for part B, okay? So this one is asking us to determine the acceleration at 3 minutes. So what is a of 3? Like that. So what we can do, first of all, is just keep differentiating it. So remember that displacement, which is like I'm 3 meters away, I'm 4 meters away. If I differentiate that, I get velocity. And if I, like, so I'm 3 meters per second, or I'm 60 kilometers per hour. But if I differentiate it again, that gives me acceleration. So what we can say, this is only just one mark, it's a calculator assumed question. So we can say a of t is equal to, and then we're just going to write our formula in from the calculator. Okay, so we'll just differentiate this one, and I'll bring it all the way down. Come on. So edit, copy, edit, paste, and I'll just differentiate it again. So interactive, transformation, calculator, I'll get there in the end. And I'll differentiate it twice, and it's just equal to 4. Okay, so it's just always equal to a constant number. So if that's equal to 4, well, it doesn't matter what value t is equal to, it's always going to be equal to 4. So a of 3 is equal to 4, and the units were kilometers per second squared, because we originally started in kilometers. Cool. All right, so the next part of the question is C, and that is asking us, determine the distance traveled during the first 8 minutes. So we want to find the distance for first 8 minutes. Okay, so the distance is, we need to find the area. I guess we need to find the area under the curve from 0 to 8 for the velocity. So we can say that our displacement is equal to the integral of velocity. Okay, and what we need to do here is figure out the distance, which always adds. So if you go back to our original graph, we can see that we enter like negative territory. Okay, we enter negative territory. Plot this guy. We're in like the minus zone here, and so we're going to get a negative value if we integrate it from 0 to 8, and because we cross the border. So what will end up happening is that with our graph, if we don't do the maths right, it'll go below and it will add this bit and subtract this bit. So there's a trick to get away with it. Okay, so first of all, we get our velocity, and we integrate it from 0 to 8. And then this is, we use our velocity equation here. And we do something tricky. We use this absolute value. So it always makes it a positive value. And that's kind of the trick that we're going to use here. Now, I guess technically we're not using the displacement equation here. It'll be the differentiated version, which really quickly was just that 4x minus by 10. And when we plot that, we see that, yeah, it does cross. So we're still going to have that same issue. So instead of using the quadratic there, we're going to be using this one, and we get a little negative here and a little positive here. So to fix that, we use the absolute value. Okay. And what we do is we say 4t minus 10 dt, and this is equal to, so we go back to our main function here, we grab that 4x value here, and we are going to find the integral, the definite integral. So math2 from 0 to 8, and we need the absolute value. Okay, so that's this guy here. So we can highlight it, and then it gives us the right value. So this is equal to 73 kilometers is the distance traveled. Traveled um, in first 8 minutes. Okay, so what you need to say is use calc here, but I think the marker will know what's going on when you use these absolute values. So let's say what if we don't use that. So if we just use that 4x minus by 10, hey, we get a different value. We're like cutting some things off here. And so that is the issue. That's why we need to use the absolute values. If you want to do it otherwise, you need to figure out when you cross and then put a minus sign in front of this guy and keep a positive sign in front of that. So the original question is in the description. You can click that to practice. Otherwise, I'm sure you found it through the website. There's heaps more questions like that. So have a look, and hopefully it will help you in your exams.